Okay, so today's notes we're looking at plotting points, finding domain, range, and then determining is it a function. A lot of the notes today are going to be reviews, so I will try to move through pretty quickly. But if you find that you need to hear something again, just pause, rewind, and rewatch. So the first thing we're talking about are just plotting points, and this is definitely something you've seen before. Points are represented as x, comma, y, with the x-coordinate telling you how far to the right. And over here on the right side, we're going to get positive x values. Over here on the left side, we're going to get negative x values. And right up and down the middle here on the y-axis, we're going to get an x value of 0. Y values, y coordinates, tell you how far up you're going, with positive being up towards the top of the graph, negative at the bottom of the graph, and 0 right along the middle. So let's plot a couple of points and just take a quick look at them. All right, I'll do this first one in red here. Let's put it right about here. So a point is generally represented by a dot. Mine's a big fat dot right there. If you look at it in terms of right-left, it is 1, 2, 3, 4 units over to the right. So the x-coordinate is going to be 4, and it is 1, 2, 3 units up. So this big giant dot here is at 4, comma, 3. Positive 4 because it's 4 to the right for the x-coordinate. Positive 3 because it's 3 up for the y-coordinate. Let's do a negative one. In blue, I'm going to plot this point right over here. A little smaller on the dot that time. All right. For this one, the x-coordinate we look at first, that's sideways. It is 1, 2, 3, 4, 5, 6, 7 units to the left. That means that we have an x value of negative 7. Negative 7 for the x value, and it is 2 units down. That means we have a y-coordinate of negative 2. One more. Let's go one that's on an axis this time. In fact, I'm going to go right here in the middle. This is a special and important point. We call this the origin. Okay, it's kind of where everything starts. This point right here is 0 units over to the right or left, and therefore the x-coordinate is 0. It is 0 units up, 0 units down, so the y-coordinate also 0. We call this the origin, 0, 0. I'm sure you guys have seen this before. But just be aware, if you got a point that's on the x or y axis, it's going to have at least one 0 in its ordered pair. So that gets you plotting points. Let's move on to the next page. Next thing we're going to talk about is a relation. It's a set of points. It might be just a few dots. It might be a straight line like this one. Might be a curved line. Or it could be any other shape. This is kind of a weird, sort of circular-ish looking oval. Each of these is a relation. In this case, we've just got 4 individual points over here on the left. That can be a relation. In this case, we have a straight line with arrows indicating that it goes on forever up to the right this way and also down to the left this way. So that's an infinite number of points, but also a relation. And then this circular-looking shape over here could also be considered a relation. It's made up of every single point along this curved line all the way around. So when we talk about a relation, just understand that we're just saying really any set of points. So that's all we mean by that word. All right. Next thing to talk about is domain and range. So when we talk about domain and range, domain is the set of all the x values for a particular relation, and the range is all y values. Notice it goes in alphabetical order with domain, starting with a D, coming first. Range starts with an R, it comes second alphabetically, just like X comes before Y in the alphabet. So domain and range, alphabetical order, just like X and Y, alphabetical order. So let's take a look at our domain and range here. Domain first, that's all the X values. So we'll go through one point at a time. And this first one appears to be at negative 1, 2, 3, 4, 5, negative 6. So this guy down here, he's got an x value of negative 6, and this is our domain. Okay, let's see if we can't make that blue. We talked about domain up top as being in blue, so why not go ahead and make it blue so we can see it the way that it looks up here in the notes be consistent. -6 is our domain value here. Let's get back to domain values. Here's a -3 on this guy. Here is a +3 on this guy. He's 3 units to the right, so that's +3. And over here, we have +4. So this is our domain. Now, next we're going to talk about our range. And we'll do this one in red, just like it is up here. Range talks about our y values. So what are our y values? Now, if you look at a list of range, we usually see it going from least to greatest. So I'm going to start with the lowest point here, which is down here at -1, 2, 3, 4. -4 would be a y value that's in this set of points in this relation. Also, here's a +2. That would be in this one. Coming up, I see 3, 4, 5 is also a value in the range. This point right here had a 5 for its y value. And then last but not least, this one has a 6 for its y value. Domain, x's, range, y's. It's just a list. Now, if you want to connect those points up, you can say this -6 for the domain, it goes with the -4. So we are just going to create a nice little line that's going to connect them up from the -6 going right over to the -4. For our -3 domain, that's the -3x value, we're talking about this point right here, it is going to have the 5 as its partner. So you see the lines crossing there. 3, it's going to have the 2 as its partner. When we're at 3 for the x, we're at 2 for the y. So we can use that arrow there. And then when we're at 4 for the x, we're way up here at 6. This one's going to come straight across. So these arrows are just a way of connecting up which x's in the domain go with which y's in the range. On to the next one. A relation is considered a function if each value in the domain has only one corresponding value in the range. Let's give you an example of a function. Let's say, we have a relation, a set of points, and maybe it's got a 2, a 3, a 5, and perhaps a 7. This is our domain. And then we're going to have a range over here. Maybe the 2 point corresponds with a 1. All right, and maybe we've got also a 6 in the range, an 8 in the range, and a 10 in the range. I'm just making up these numbers. And let's say it connects up kind of like this. We said the 2 was going to go with the 1. So we have 2, 1 is a point in this relation. Let's say the 3 goes with the 8. So 3, 8 would also be a point here. Maybe the 5 goes with the 10. So it works. And perhaps the 7 goes with the 6. There's a 7, 6 in this relation. So this would be an example of a function. And the reason that it's a function is that each x value in the domain only connects up with one single value in the range. Okay, we can't have an x value that gives us 2 different y values as its result. So an example of not a function might be something like what I'm going to do over here. Say I've got maybe a 3 in my domain and a 4 in my domain. And when I come over here to the range, maybe this 3, the 3 connects up to a 2, but it also connects up to a 5. So This relation includes 3, 2, and 3, 5. Maybe the 4 connects up to a 7. Here's the issue that makes this one not a function. This 3 is connecting up to 2 different points. So we don't like that. It's not a function if that happens. The 4 is fine. It just connects to a single point here. It's a 7. This is not a function. And when you're looking at this thing, maybe you want to see it listed off as points. So for this first one, we would have had ordered pairs of 2, 1, 3, 8, 5, 10, and 7, 6. Notice it is a function because each x value is only appearing one time. It's just giving you a single y value. Now over here, we have 3, 2, but we also have 3, 5. And then, of course, we have 4, 7. But it's really these two that are the issue. Okay? The reason this is not a function is because the 3 is giving us 2 different values. So what happens when the x value is 3? Well, we don't really know. Maybe it turns out to be 2, and maybe it turns out to be 5. That's not a function. All right. If it's a function, each x value should only lead you to one y value. So not a function if the 3 leads you in 2 different directions. All right. Another way to test if it's a function is the vertical line test. If it's a function, a vertical line will never pass through it more than once. And if you got something on paper, you could certainly test it out with the edge of a piece of paper or something. I'm going to build myself a little vertical line here, and I'm just going to drag it across. And we're going to see, is this thing a function? Okay, it's just hitting that point once, so we're fine with that. Still dragging along, hits that point once, so we're okay. Hits that point once, we're okay. Each x value so far has only had one point, one y value for each x. And then last but not least, it drags over this point, but it just hits it once. So that's okay. Yes, this is a function. Yes. Now, on to the next one. This line here, as I drag it across, I'm only hitting one point at a time. So this thing is passing the vertical line test. All right. Each x value has only one y value. So yes, this one is a function. But this last one over here, we are going to have an issue with this guy. He is not going to be a function, and here's why. I can pause my little vertical line test, and look, I got a point right up here and a point right up here. So if the x value happens to be negative 2, 3, 4, 5, 6, negative 6. If the x value is negative 6, I don't know what the y value is. Maybe it's 3, but maybe it's down here around negative 5. So I don't know. And this thing continues to fail the vertical line test all the way across. It's failing it here at negative 2. It's failing it here at negative 1. It's failing it at 0. I've got 2 y values for each of these x values. So this thing is definitely not a function. It's failing the vertical line test all the way across. No, it is not a function. So that kind of wraps us up here as far as what is a function, what is not a function. Thank you.